Welcome to Turn Right Machine Works. My name is Keith. We took and hacked off a piece of 1 3/4 square steel coal roll, and we went ahead and took a turbo mill and we roughed it out. We took a finishing 5/8 finishing end mill and made a pass down through there and got a nice clean surface in there to a rough depth and finished sides, and we got a nice tight, there's no play here at all. It takes a little bit of work to push it, move it in here. That's what we kind of want. We want that pivot to be tight around the pin, which is pretty tight. I mean, we might have 1,000 clearance in there. This pin is a couple thousandths under 5/8, and our reamed our hole right at 5/8. But we got the side hold, and we want to make sure that we're not going to be doing the twisting on our drill head. So we've got a good start here on the pivot. Now we're going to pull it out of here, and we're going to start bringing some shape that's going to let it have some clearance and maneuverability, and an area where we can tack weld it or some kind of mounting to our jig plate there. It's not even out of the realm that we might drill from underneath and drill and tap to mount this on there. A couple different ideas we're thinking about right now, but we're going to get it pulled out of here. We're going to deburr dress it, and we're going to plan for our cross hole, and then we're going to whittle from that cross hole. We'll whittle some clearance off of it. Whenever you bring a table down, whether it be a mill, the Bridgeport, the Kerning Trekker, horizontal boring mill, bringing it up and down the head or whatever, you should pretty well, once you go down, crank the backlash out so everything is supporting up and underneath the table with your feed screw and stuff there, just so you don't have a false sense or have it drop when it's important for a depth reading, things like that. Just kind of keep, a little tip that I just thought about when I was lowering that down. Alright, a little slower speed for this drill. Now we picked this location here. We picked this location so that this was just clearing off the bottom, and we went a little bit on the forward side here because we wanted this to hang out on the front of our jig a little bit, give us the opportunity if we have to increase or get some more depth on that Woodruff key cutter, the strength, or this, we may not take too much of this off because it's going to help guide or hold that rigid, so we might be just deburring. But we got this tail part sticking out past the end here, and we'll be able to join that for our adjustment in and out, and possibly down below here we can put the set screw to create an adjustable stop for our depth. This is a real old 5/8 reamer I've had for a long time, and I can run it in the Morris taper or in the straight shank, and I turned this a long time ago. I've hand sharpened it on the end many times. It still cuts. It cuts a very, very tight hole. In fact, sometimes it's even just a little bit undersized on the 5/8, and that's kind of why I chose it for this job here as well, because our cross pin is a couple thousandths under the 5/8 nominal diameter. Alright, let's see if we can. I got a burr there. I'm going to have to do some filing and deep burring in there before that goes in. I'm not. Alright, we'll take care of that. Oh, sweet. I'm looking for that. Okay, I don't want no rattle or situation of my jig failing. You know, the choice of tool to adapt is the customers. We got some good action there. All right, and now we're gonna go ahead and set this on our jig plate. We'll have to put our aluminum back in here, clear off our table. Alright, we just got a pair of vice grips reach overs there holding the block down on our plate there. We're not planning exactly where we're at center to center. We want to see the operation here. This is almost like a miniature coal saw. Okay, but anyway, our action here is really nice. I like how firm it feels. Now the one thing that we warned about and was concerned about at the very beginning was the amount of play that the bearing line here in the 90-degree head has. And when it's mounted rigid, you can really feel exactly what it is. Whether that's going to affect the operation of this thing is yet to be known. But if it was, you know, I think it's worthwhile to go ahead and pull this 90-degree gearbox apart, slap in a couple new bearings, bring that wobble down to as tight as you can possibly make it, and it'd probably give you the best chance to having the highest quality hand machined plunge cut, slide, replunge keyway that you could possibly have. All right, we're real happy with this. We're going to go ahead and set up this block and take a 1/4 inch off the bottom. We're happy with how much travel and everything else we have right here, but if we go ahead and we take a 1/4 inch off the bottom of there, then we will have that much more depth capabilities, and we won't be short of that at any one time. And also a set screw through the bottom would be a very good adjustment for the front side of this to control a stop for the depth. And then once we have that located, we'll go ahead and pick a spot on that plate for our block, and we're either going to drill and bolt it, or we're going to take the MIG and we're going to weld it to the plate. And then we're just going to go ahead and we're just about ready to make our hand crank, however we're going to attach that. And I got a couple ideas in the head to play with right now, so I'll be thinking about that while this is cutting. this is set up. I put a 5/8 tool bit down in here so that we had something to clamp on. It fit in there pretty snug, so I wasn't excess squeezing on that section there. We're going to do this in 2 passes. I cranked in 1/8 of an inch of depth on this 2-inch index shell here, and it looks like she's taking a pretty good bite there. Alright, I set you up off the end here. What we did is these are 2 parallel 7/8 of an inch thick, and this is a 1/4 inch cutter here. So 7/8 on each side would pretty well take you equal to, let me get over here, to the width or diameter. Now we're just a little bit shy, about 50 thousandths to go on this way here, and we're pretty close to the center line of our slots over here, and we have pretty much set 7/8 of an inch right there. So we're going to call this a rough center, and this is without having to modify these cutters at all. So you could buy this cutter if this snaps off right there because it's a weak point, and you have to put another one in and continue on or try again. So this is somewhat exactly where we're going to have it. We're going to mark this. We're going to go on in there and we're going to lay a parallel along here, and we're going to jig this up, and we're going to go ahead and put a well bead at each end of that after we round off this edge a little bit. It's the only place I see that it actually needs. It's a little tight right in here where this comes like this. This 9/16 can be loosened up, and the head could be pivoted in any of the directions it needs to be. And then that'll give us a chance to go ahead and come in here, and then we'll start planning our jack screw here. This is a National Course grade 8 bolt, fully threaded, about 3 inches long, with a head like this. And we went ahead and we faced it, skimmed the OD down to a round diameter. We're going to go ahead and poke a 3/8 hole down into it, and then it's going to be our feed nut or our feed screw for the head itself. And we're going to silver solder an extension in here, which will be the other part of the thrust, and the handle crank. Alright, this is a heavy hex nut, and we've got it set up on the side, and we're centered with the flat. We're going to drill a 1/4 inch hole straight through this, which is going to be a trunnion pivot for the nut. And we'll show you how that comes into play here as we're assembling. Okay, we've got a hole through there. This nut will be able to pivot back and forth like this. Now we're going to cut off some 1/4 inch rod, and we're going to go ahead and get it silver soldered in there.